So when testing for regional effects in the probability given a medium score, so it's the same basic rhyme and reason as you've seen before, both in terms of the two R steps, first the computing the model and then summarising the results, and in terms of the R command used here, ELMMPQL. So for the first step, compute the model, so medium 2 goes to GLM QL, medium relates to region, the random term is related to constant value given the hotel, and then just to clarify, this is a probability model, so family equals binomial. As before, show the results using a separate summary command. So lots of this is familiar, even though this is a harder generalized linear mixed model, but it's the same rhyme and rhythm for the R commands and also for the interpretation of the results. Now I'll go through the interpretation of the results in a moment, just to say here that the thing to focus on would be the fixed effects. And if you focus on the fixed effects, then you get almost exactly the same interpretation and the way of working as before when we looked at the straightforward logistic generalized linear model. So the results that you get from the summary command, so rather a lot in this case. Again, the main emphasis here would be on the fixed effects term. This will then give you a set of results that are almost identical to the logistic regression results in terms of the interpretation. So here we've got a wodge of t statistics for these fixed effects terms, and the interesting part of the table, as always, is from the second row downwards. And what we would expect to find, if we've got everything correct, is that none of these should be significant at the 5% level, precisely because all the effects in the system should be captured by, when we looked at the equations for the probability of giving a high score and the probability of giving a low score. And in this case, if we look at the final column, we should see that none of these p-values are less than 0.05, with the exception of the intercept term. So we can be sure that when we've looked at this system, any regional effect has been captured by looking at first the probability of getting a high score, and then secondly by the probability of getting a low score. So this is a redundant step, but in this case, the practical data example, it's worth just checking, just so that we know we haven't definitely missed anything. And as I said before, this process of always looking for checks, very important for accounting and finance and for econometrics here. So in terms of the interpretation then, so no evidence, p bigger than 0.05, equivalent to the t-values or less than 2 of a regional effect in this case. So this is consistent with what we expected to find. We've got no further evidence of any regional effects in the probability of getting a medium score. Equivalently, this means that in our system with 3 categorizations, all the regional effects are identified in terms of the probability of getting a high score and the probability of getting a low score. So the theory tells us that that third step should be redundant. We don't get any further evidence of a regional effect, so we can be more sure in our interpretation and more sure that we haven't made an obvious mistake here. So as it said there on the slide, though technically a redundant step, it serves as a cross-check of our early results. It means you can be more confident that our earlier analysis is correct. So this sort of set of robustness checks that we've done here, I think this would be an excellent thing for dissertation students to bear in mind, because this is going to push very quickly, I think, to the limit you can naturally expect dissertation students to achieve, and all the time I think looking at these separate cross checks just to make sure you haven't made a mistake, very important for econometrics and for accounting and finance more generally. I wanted to give here an extra numerical example of calculating the probability a London respondent gives a medium score. So some practice here in terms of the mechanical calculations, but I wanted to sort of try and give you as well another example for some of the checks that you might perform. Here would be to set the log of the probability of a 1 minus probability, the log odds, to be equal to the regression equation. Here this would relate to the fixed effects equation on slide 6.16. So we're going to do this here, same calculation as you've seen before. So what you should get is that P over 1 minus P equals the exponential of the regression equation, and the probability equals the regression equation over 1 plus the exponential of the regression equation. So it comes out as 0.174 in this case. Okay, so some extra sort of practice of the hand calculations. This is probably more important than years when classes sit a final exam as part of the assessment. Okay, it's still worthwhile, I think, just to sort of see how the thing hangs together and what these aspects of the regression equations and the R output really mean. I also, as promised, wanted to just show you an extra check that might be possible using this model on the next slide. So I wanted to give a second example here just to illustrate the sorts of checks that you might be able to do with these models and with these numerical calculations. So in years when people sit a final exam, these sorts of numerical manipulations are important. Less so this year, but I just wanted to try and get you used to the sorts of robustness checks that you might be able to perform. So here what we've got is no significant regional effects in the probability of awarding a medium score, so you'd expect similar answers to both London and Scotland, whereas when we had evidence of a significant difference, you got markedly different numerical calculation answers. So the same set of commands as before then, so set the log of the probability of 1 minus probability equation. This is referring to the fixed effects terms. Same as above, so the odds ratio P over 1 minus P equals the exponential of the regression equation. Exponential of the regression equation over 1 plus the exponential of the regression equation. And sanity check. Both answers are very similar, reflecting here no statistically significant evidence for differences between London and Scotland. So always look for these separate cross checks whenever you're looking at econometrics. Final journal reference then, so it would be rated a 2-star journal, so not necessarily so highly rated, but we had to work very hard to get this publication. All sorts of interesting stories with the reviewer, and what I wanted to say as well is, importantly, this is a practical example that came from an industrial problem, namely the problem in the electricity industry that the regulatory fines are imposed by way of customer satisfaction scores, and there are concerns that these customer satisfaction scores contain subtle regional bias.